Hi everyone, I'm Shubham Jawar. I'm a master teacher at Vedantu. We are discussing KVPY 2020 SX Part 1 Mathematics, and the question for this video is this. Let R be the set of all real numbers and there will be function defined from all real values to all real values. That means codomain being all real values and also domain being all real values. Be a continuous function. Suppose mod of f of x minus f of y is greater than or equal to mod of x minus y for all real numbers x and y. Then there are four options. Basically, we need to comment upon whether f is 1, 1 or not, onto or not. So let's solve it. Here, if you see carefully, for f of x to be many one, there should exist x1 which is not equal to x2, for which f of x1 equal to f of x2. But that's not possible. Why? Because if it were so, then you would have when you put x to be x1 and y to be x2, f of x1 minus f of x2 would supposedly be 0 and mod of 0 is 0, given that f of x1 equal to f of x2 we are considering, greater than or equal to mod of x1 minus x2. Now since x1 and x2 are supposed to be distinct values, then this is supposed to be something this is in fact supposed to be something positive, not just non-negative. So 0 greater than or equal to something positive is just not possible. Yeah, so that means f of x has to be 1, 1 for sure. Now let's talk about whether it is onto or not. So here let's say x is not equal to y. Rather, let's take x to be a plus h and y to be a, where a is some real value. Here that would mean that and h is not equal to 0. So that would mean x minus y is strictly non-zero. That means mod of x minus y is strictly positive. So as I cross multiply, which I can, why? Because this mod of x minus y would be strictly positive, and as I cross multiply something positive, the sign of inequality remains the same. So after cross multiplication, this is what we would get. In fact, mod of numerator divided by mod of denominator, I may write as mod of this whole expression. Now let me take limit h tending to 0 on both sides. On right hand side, when you do limit h tending to 0, anyway it is constant 1 and it would remain so. And since modulus function is a continuous function, so you may take this limit inside. So mod of limit h tending to 0, f of a plus h minus f of a divided by h is greater than or equal to 1. This essentially means mod of f prime a is greater than or equal to 1. Now since this expression holds for every x and every y, that means this expression will hold for every a. So mod of f prime a is greater than or equal to 1 for every a. Now that essentially means two possibilities. F prime x is greater than or equal to 1 for every x, or f prime x is less than or equal to minus 1 for every x. Now here the point is both can't occur simultaneously. That means it is not possible that for some x, f prime x is greater than or equal to 1 and for some other x, f prime x is less than or equal to minus 1. For a simple reason, you may say, what about this, sir? Derivative greater than or equal to 1 and derivative less than or equal to minus 1. No, this is not possible. Why? Because we have already proved that f of x is 1, 1. So this would not be possible. Now you may say, sir, what about this, derivative being greater than or equal to 1 for some part of x and, negative for some other part of x, still being 1, 1. But here, the function is given to be continuous. So even this is not possible. Yeah, because here in some place there is supposed to be discontinuity for sure. If you try to maintain that f of x is 1, 1 and, both of these, that means f prime x greater than or equal to 1, f prime x less than or equal to 1 can occur simultaneously. Or rather can occur for some x and, other can occur for some other x. So that means all these possibilities have to be rejected. Now very simply, so which I have written straightforward, and I have justified it. Why am I saying that f prime x is greater than equal to 1 for every x, or f prime x is less than equal to minus 1 for every x? Because no other possibility is feasible here. So now whether derivative is greater than equal to 1 for every x or less than equal to minus 1 for every x, it is either strictly increasing or strictly decreasing, in which case it will surely be onto. So that means D is the correct answer. F is necessarily 1, 1 and also necessarily onto. Thanks for listening. Stay tuned for the next question.